Welcome back to the discussion. We are presenting a question on longitudes and latitudes, KCSE 1995, paper 1, number 24. And the question we have reads, an aeroplane flies from a point A, 1 degrees 15 minutes south, 37 degrees east, to a point B directly north of A. We have a point A, which is 1 degree 15 minutes south. Those 15 minutes you divide by 60, you get a quarter. That means this is the same as 1.25 degrees south and 37 degrees east. This aeroplane flies directly north of A to another point B. We do not know the latitude position of B, but the longitude remains 37 degrees east. The first part of the question, from a point B, the aeroplane flies due west to another point C. That means it is going to maintain the same latitude, but the longitude is different. The longitude of C is going to be different, but they have told us the longitude of C is 23 degrees west. So what we are supposed to calculate, it is the latitude position of B, which is also going to be the latitude position of a point C. The first part of the question, which is A Roman 1, calculate the latitude position of B. So to get the latitude position of B, remember we have been told that AB subtends 45 degrees at the center. That means to get the latitude of B, we are going to have the angle at the center, which is 45, minus 1.25, translating to 43.75 degrees. That is what we are going to have here, 43.75. And also at point C, we are going to have the same angle, 43.75 degrees north. So having done that, we can now proceed to Roman 2 of the question. And in Roman 2, we are supposed to find the distance traveled by the aeroplane between B and C. Remember, we have B, which is 43.75 degrees north, 37 degrees east. We also have a point C, which is 47.75, that is 43.75 degrees, which is north, but the longitude is 23 degrees east. You realize the 2 points are lying along a small circle since they share the latitude. Therefore, we are supposed to calculate the distance between point B and C. To get the distance between point B and C in kilometers, we are going to take the longitude difference, divide by 360 times twice pi r, then cos the latitude position. That is the formula of getting the distance between any 2 points that lie along a latitude or simply a small circle. To get the longitude difference, which is going to be noted by alpha, we look at the longitude positions. One is to the east and another one is to the west. C is 23 degrees west, and if it is east-west, we are going to add the 2. That is 37 plus 23, giving us 60 degrees. Then our theta, which is the latitude position, is going to be 43.75. Once we have gotten that, we now substitute the 2 into the formula to get the distance. So the distance CB will be given by the longitude difference, which is 60 over 360 times 2 times 22 over 7 times the radius, which is 6370, then cos of the latitude, which is 43.75. And this one is the formula of getting the distance in kilometers. Once you have done that, we can now simplify this. This is going to be 60 over 360 times 2 times 22 over 7 times 6370 times the cos of 43.75, which is 0.7224. If you use your calculator well, you are going to get an answer equivalent to 4820.816 kilometers. Once we have done that, we move to part B of the question. And part B of the question says, the aeroplane left B at 1:00 a.m. local time when the aeroplane was leaving B. What is the local time at C? We can still draw this or represent it in form of a number line. We have point B and also a point C. C is 43.75 degrees north, but 23 degrees west, and B is 43.75 degrees north, but 37 degrees east. So for us to be able to get the local time at a point C, C is behind B, and we know the time at B is 1 p.m. So from here now we know what causes, actually it's AM, what causes the difference in time is the longitude, and we are going to start by getting the longitude difference. The longitude difference has also been found to be 23 plus 37, which is 60 degrees. And we know for every 1 degree, the Earth rotates or takes 4 minutes. What about the 60 degrees? This one is going to be 60 times 4. You divide by 1, giving us 240 minutes. If you divide this by 60, we are going to get a difference of 4 hours. In this case, to get the local time at C, since it is behind, we are going to subtract the 4 hours to get the local time at that particular point. In this case, we are going to start from 1 a.m. This is at night. We minus 4 hours, and this will land us at 9:00 p.m. That is the time at point C. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second and subscribe, because every subscription supports us directly. Thank you and welcome.